To complete Goal 12, I hope that you have already graphed sine and cosine and listed your comparisons and your contrasts of the two graphs of those two functions. I want to point out a few things that I hope you notice about the functions. First of all, my light green is the graph of sine and the dark blue is the graph of cosine. Some comparisons, some things that are the same. I noticed that both of these functions have the same max and the same min. So I know that the range for both functions is -1 to 1. Also, the domain of these functions. I know that in this drawing, we've only sketched them from 0 to 2 pi according to what I asked you to do. But if we continued to draw pattern or period after period after period, the domain is -infinity to +infinity for both functions. I know that both functions have a period. Remember, that's the length of one cycle, equivalent to 2 pi radians. And why would that period repeat every 2 pi radians? We know that one rotation around a circle is also equivalent to 2 pi radians. So it would make sense that the function would repeat every 2 pi radians on a coordinate plane. Something that's different about the two functions that I hope you notice is their starting point. I want you to think of these graphs as the parent function, and so the parent function at 0 radians, the parent function for sine begins at the origin. 0, 0 is its starting point, while cosine has its starting point at 0, 1. So to give a general term to 0, 0, I would call that the origin, but 0, 1 is the maximum of cosine. So sine will always start at the origin, the parent function, and the parent function for cosine will always begin at our maximum. So that brings me to a new term that I want to introduce to you. We've discussed the word period, and now I want to discuss the word called amplitude. To discuss amplitude, we're going to look at several of the functions that you graphed in practice 12. So turn now to practice 12, numbers 1 through 3. Okay, so hopefully you've already graphed this yourself and checked it, not just copying down, so you can actually learn what's going on here. So we're talking about the term amplitude. First of all, what did you answer for number 4? What can be said about the graphs of sine as the coefficient of sine changes? I hope you said that you noticed that the function stretches and shrinks vertically. And if you look at number 1, y equals 2 sine of x, the max is 2, the min is -2. Number 2, y equals half sine x, the max is 1/2, the min is -1/2. Y equals -2 sine of x, the max is 2 and the min is -2. The last question on this page says variation of y equals sine x. So our variations, the first variation that I want to discuss would be when the coefficient of sine and cosine change, and we will denote that by capital A. So capital A represents the change in the coefficient for sine and cosine. And finding the absolute value of A is where we calculate amplitude. So amplitude is equal to the absolute value of A. In number 3, A was equal to -2, so the amplitude is equivalent to +2. Notice we had a max of 2 and a min of -2. In example 2, A is equal to 1/2, and the amplitude is equal to 1/2. We have a max of 1/2 and a min of 1/2. Based on that, let's define amplitude. We can say that amplitude is the distance above and below the x-axis. Our max is 1/2 unit above and 1/2 unit below the x-axis. In number 3, our max is 2 units above and 2 units below. So our amplitude just shows us how far above and below the x-axis the function is. And the same thing would hold for cosine. So make sure that you have defined amplitude and period. And I'll see you in class. Thank you.